Good morning, everyone. My name is Eric. I'm doing my PhD with Felipe, and I'm going to talk about the third chapter of my PhD. And the title is about the influence of mixing proportion and also competition in the young mixed stands of both pine and oak. Okay, so as the conference is all about forests, I want to bring your mind about the importance of forests. And we all know the importance of forests. Today's world, there are a lot of climate change programs talking about the importance of forests and why we should have forests. But due to this climate change, there's a new adaptation or a new management that has been taking place. And this management is called the mixed stands. So mixed forest is one of the solutions to this climate change. In the traditional way or previously, we used to have the pure stands, but now, mostly in Europe, they are adapting to the mixed stands to combat against this climate change. So therefore, there are so many research that has been done on this mixed forest, talking about the importance of mixed forest in terms of pests and diseases, in terms of wildfire, in terms of productivity. So there's higher productivity. That is why the forest is moving towards the mixed stands. However, all this research that has been done, they are missing information about the young stands. So today there are a lot of replanting, reforestation, but there are not much information. Most of the information are being done on the mature trees, the trees that are big. However, my research is focalized on the small stands, trees that are below 10 years, they are between 10 years, so very small. Why is this very important? Because when we are accounting for this carbon, we need to take into account the small stands. And therefore, my research is going to focus on these young stands. But these young stands, we're going to look at the competition in these young stands and the mixing proportion. Okay, so that goes with the research question that is very important in my work, is to know if the competition in the mixed stands, so if you take a mixed stands of pine and oak with young stands, not the big stands, is this competition affecting the biomass in this mixed stands? And also, is the mixing proportion affecting the biomass? So if you have a stand with one tree, how many trees are surrounded that is the opposite or the other species? A lot of research has been done, as I said, and we want to know whether for the young stands, is it the same as the research says? So in my study area, what we did was that we have 9 different plots. 3 plots are control plots that are in the color red. The orange color are in the light thinning, and the green color is a heavy thinning. So it means that the density is very low. I'll use this diagram to explain a general overview about the work. So you have the pine in the middle. The first one, we have the pine in the middle, and it's surrounded by different species. But this species, we have only 2 different types of species, the pine and the oak. And so this is how the stands are. And you have an oak here surrounded with different species. And consider these are young stands. So what you do is that in the forest, you take the DBH of this. These are called the target trees. You take the DBH of this and the height of this tree. And then you take the distance of the neighboring trees all around it. In order to know this radius, you need to multiply 0.25 times this target tree to know the maximum radius you need to do your neighborhood. So you calculate and know all the stands. So after collecting this data, what to proceed? I first of all used the mixed models, and we realized that our data was not normally distributed. So we had to change it to the generalized linear modeling. And this will help us to be able to move forward. We use the plot as a random effect, and we use this. So this, you put the competition factor in the model to be able to know if the competition factor is significant or not. So for the first part, this is the model we use. If we're able to know that it's not important, now when we are building equations or biomass equation for it, we do not include competition. But if its competition is very significant, then we have to include competition if we are building the biomass equation. So we move forward to the Dirichlet regression. Why the Dirichlet regression? Because this regression is an advanced regression which takes into account the fixed effect and the random effect. And also, when you're able to add the various biomass proportions, the stem, the branches, and the leaves, they sum up to the total. That is why we use this regression. So if you've not heard about it, you can read more about it. Dirichlet regression. It's very important, but it's a little bit advanced regression. So not to go too deeper, when I'm doing the model selection, what you take into account is these factors. The significance, the RSE, the lowest AIC, and the lowest RMSE. So here, what you should know is the model that we selected. These are the two. One, this is for the oak, and this is for the pine, and the criteria we use for the selection. Don't be too much confused here. Just focus on this criteria, and then the equation we select as the best equation. So in a brief, we put competition and mixing proportion into the equation. If it's significant, we add it to the equation. If it's not significant, we take it out of the equation. In my results, we find out that competition and mixed proportion was not significant. So in the equation, we did not add them. However, all the other research were done on the mature trees, and competition was very significant, and it was added into the equation. So why the difference? We could know that there's a difference because you can understand that when a child is growing, at our age, we grow very slow. But when you're a child, you grow very fast. It's the same thing like the trees. When the trees are young, they grow very fast. So regardless of the competition, regardless of the proportion they have, they still grow. Biomass is still more. So, but the mature trees is not the same. For mature trees, when there is competition, they don't grow more, they grow less. So this is one of the interesting results that we found, that mixing, proportion, and competition did not have any effect on the biomass. Why? Because they are young stands, and young stands, they grow faster and they grow more. So that is our finding. Okay, so thank you very much, and all questions are welcome.